My name is Flavio, and I'm the founder and CTO of Relab. When I started my chemistry study in Lund University in Sweden in the 70s, I was amazed because the course started with a 1 week glass blowing course. For me, this was totally new, but it was also necessary because at that time laboratories they were full of glassware. Glasswares were everything: test tube, plates, flasks, uh, whatever. No, and all the chemistry and biochemistry was based on glass and glassware. And of course, after the use, we have to wash, and this was cumbersome because, especially chemistry, sometimes the residues will attach very hard to the glass flasks, and they were very tough to clean. In any case, it was a very interesting course, but during the course, during my education in Lund, something changed. A German company introduced a micro uh, tube, and this tube was 1,000 times decrease of the normal test tube. The test tube was 10 milliliter, 10 milliliter tubes that we used to use. And suddenly there were those small plastic tubes and the reaction volume, it was not anymore 10 milliliters, but 110 to 100 microliters. That is 1,000 times a reduction in reagents and reduction in the size of the samples. Also, it allows for the multiplexing. It's not only one tubes, so we develop pipettes, we develop robotics, so that we can handle hundreds, thousands of tubes, even in plates, in so-called microteeter plates, at the same time. This has changed the way we do science. It's not only a reduction in the amount of chemicals that are necessary, but even the paradigm of science has changed. Plastics has helped to move the paradigm of science from a hypothesis driven science to a massive parallel and data driven science it is today. So today in the laboratory is full of small plastic tubes and plates, robots, and lots of plastic pipettes that handle for liquid handling. Everything is based on plastics. And what is, you cannot take out the plastics. If you do that, we go back 60 years in our science. The way of doing science will change. So it's very difficult to abate. Now, this advancement of the plastics in the laboratory has, of course, many advantages. It has helped to speed the science, but it has also a backside. We produce an enormous amount of plastic waste. To be exactly, 15 million tons per year globally. And in fact, this was before the pandemics. I would say after pandemics, you can add here 3 millions at least. So we would be around 18 million tons per year of plastic waste. None of this is recyclable. So all these 80 million tons of plastic waste, they go either to incineration in the more advanced countries, or even worse, into landfills, where they of course come out and contribute to the tremendous plastic pollution, the problem that we all have. After my graduation in Sweden, I did my career in Germany producing plastics. So I have dedicated my life to produce a lot of different forms and derivatized and functionalized plastics, most for life science. And at that time, we did not really thought about the environmental implications, sustainability. It was not in our agenda. Only much later in my career, when I was close to my retirement, I started thinking about that. Also pressed by my students and my young colleagues, they brought to me the issue of sustainability. Now, close to my retirement, I start, of course, thinking in the form of solving this problem. And as a chemist, I firmly believe the solution to the plastic pollution problem, lies in the chemical structure of the plastics. Now, thinking, what is plastics? Plastics are long chain of carbon molecules, macromolecules of polymer, and each carbon unit has at least two hydrogens attached to it. So plastics are long chain molecules composed essentially of carbon and hydrogen. Now, carbon and hydrogen, you may have know, it is a salt molecule. So the chemical industry said, but also renewable carbon is what the industry is looking for in order to reduce its carbon footprint, in order to be free from the fossil lock-in. So we can use plastics because they are hydrocarbon in substitution to fossil oil and fossil gas for the production of all the chemistry, pharmaceutical, new plastics, and all the chemical entities as renewable chemistry. So plastics is a solution to their own problem, so to speak. So it is possible, I thought, to develop that. And in the last 10 years or so, 15 years to become more close to the truth, we developed a technology that allows us to convert in low temperature and low pressure carbon plastics to syngas. And syngas is this gas resulting from the plastic complete degradation composed of carbon in the form of carbon monoxide and hydrogen. There is no emission in this process. There is no production of CO2. This gas is not intended to be burned because if you burn the gas, you will produce CO2. This gas is intended for producing chemistry, new chemistry, chemical products, chemical, including new plastics in a circular fashion. So we have developed a circular solution for the plastic problem. We have now certified or validated this technology and are now starting the deployment, constructing real business case where you can take the plastics. We are geared to the laboratory plastics, the research laboratory plastic, and convert this research laboratory plastic waste into chemicals, renewable chemicals, and new plastics. So this is what we are doing. And thank you for listening.